Good afternoon and good evening. I'm Neil Fraser, President of Medtronic of Canada, and this is our fourth podcast. We're just delighted to have all of you here with us tonight, and we want to learn about what you've been working on. But as the focus of this is on the next 100 years, we want to stretch your minds to talk about what you think the next 100 years is going to look like from the standpoint of science and technology development in Canada and globally. I'm going to ask Renee Barlow, who's the Executive Director of Youth Science Canada, if he could just talk briefly about his organization and how he came to know all of you. So over to you, Renee.
Oh, thanks very much. Youth Science Canada is a national charity dedicated to fueling the curiosity of youth through STEM or science, technology, engineering, and mathematics projects. And so every year, and we've been doing this now for almost 60 years, this will be the 60th Canada-wide Science Fair this year. But for 60 years, we've been engaging youth in doing these STEM projects. And we start with somewhere around 500,000 students across the country who do some kind of project, whether it's at home, in their garage, at school, wherever. And then about 25,000 of those end up at regional science fairs, about 100 regional fairs across the country. And then about 500 of those are selected to the Canada-wide Science Fair, the national championships of science fairs in Canada. And so the three students that we have here today were participants, finalists in the Canada-wide Science Fair 2021, which was held virtually in this past May.
We're going to move ahead and get each of our students to introduce yourselves and talk about your science project.
My name is Keanu Chan. I'm 14 years old and from Cranbrook, British Columbia. And I have done science fairs for all my life. And I am currently on a project dealing with spines and spinal discs. And when they get damaged or ruptured, how I can put essentially a balloon inside of a spine disc to act like a normal spine disc.
Very, very exciting. Thank you. Catherine.
Hi everyone, my name is Catherine. I am 17 years old and from Vancouver, British Columbia. I've been participating in science fairs since grade 6, and this year my project surrounds nano-antioxidants and specifically how they combat oxidative stress in one's body. And this is very critical when considering neurodegenerative diseases whose primary cause is this oxidative stress.
Fabulous. Hardit.
Hi, my name is Hardit Singh. I'm a grade 10 student from Waterloo, Ontario. I love science fairs and I've been participating in them since grade 7. The project I'm currently working on is called Specular, and it is a low-cost teleophthalmology platform to provide people-centered eye care. So I have low-cost imagers that can take a picture of the inside of your eye, the back of the eye, the retina, and then those pictures are analyzed using artificial intelligence to classify them for disease.
Wow, those are three very impressive projects. Congratulations to all of you. Now, I'm curious to know what first sparked your interest in science?
The reason why I originally got into science fairs was actually because, since kindergarten, my elementary school made it mandatory that we went into the science fair. And I just kind of fell in love with it instantly, just with the little fun little projects that I did when I was little, and then slowly making them more proper, more scientific, and then actually to the point where I went to the Canada-wide Science Fair.
Keanu, I just wondered if you maybe could talk a little bit about those early projects, because quite clearly the very first thing that you came up with was not I want to cure degenerative spinal disease. Give us some idea of what those projects were like and what you did.
Yeah, so I remember my first project was called Splish Splash Should I Be Taking a Bath? So I went and tested how much water I used in a bath, and then how much water I used when I showered. And I found that showering was better in terms of water use. And yeah, that was my first project. And then another year, like the classic science project, which plants will grow better with different types of soil. So yeah, nice and simple projects, and now we're here.
You're still, in high school. What do you see in the future? Like, what are you going to pursue as careers? What will you study in university? And what's your goal?
So for me, I definitely first want to pursue an undergraduate degree in health sciences or health studies. And that really interests me because it's such an interdisciplinary approach. It's not, only science, but it combines so many aspects that we encounter in our everyday life that do influence science and do influence the future of science. Leading research and graduate school is definitely down the road. But my first step is health sciences or health studies.
For me, my plan once I graduate is to go maybe to UBC, a university that has a good science program that I could eventually get into med school because I want to be a specialized physician. And then I'll continue, and maybe in the summer I'll do some type of research project because I need to continue having my own path where I can ask questions and try and answer them and continue with this whole science fair kind of mindset.
So I'm particularly interested in computer science and engineering. So my plan is in the future to take like a degree in combining computer science with engineering. And I find that with that skill set, I can engineer and build things to solve various different problems around me. In the future, potentially, I could see myself building my own company to develop these innovations using my skills, using these skills with engineering.
Renee, you've been a science teacher, actually a very much recognized science teacher. What are your thoughts about integrating some kind of entrepreneurial skills into the program somewhere? Where do you think that would make sense?
Yeah, I think it's a really good idea. And at Youth Science Canada, we started that about 5 or 6 years ago, actually, in partnership with York University, the Lausanne School of Engineering. And we select some students from the Canada-wide Fair who either show some kind of entrepreneurial spirit or their project shows some kind of commercial potential. And then we do a week-long workshop with them on how to potentially convert your project from a project into a company or a product, and then and they have the opportunity to sort of look at what it takes to build a company, what it takes to commercialize a product, and so we're working on it in that regard. In general, I would say adults underestimate the capacity and capability of youth, and they don't realize necessarily that youth bring this incredible perspective and vision to problems and questions. They don't suffer from the same restrictions. They're not as bound by we tried this before and it didn't work, or it cost too much money or whatever. And there's a freedom that I think is really important there. And I'm kind of curious with the students around what they think can be done to help encourage youth to feel more confident in their ideas and make those help them turn those ideas actually into some kind of a project or a passion that they work on. Because I would say in many cases, the adults and the educational system tend to discourage that kind of activity as opposed to encourage it.
Hardit, how do we get other students involved in science that maybe are discouraged?
I think a lot of it lies in preventing it from being defined as success or failure. Your ideas being defined as success or failure, and how like the tendency to also put grades on things, like a science fair, definitely like reduces the students' ability to think of their own ideas instead of just fitting into some model. I definitely think that there should be less emphasis on that failure or success. It's not really a failure. It's more of a stepping stone to move up and find a better idea. You can relearn from that idea and develop a new one. And that would definitely encourage many people.
Listening to all of you, you make such good sense. And I'm wondering, have you had teachers or other mentors in your life who've inspired you to think the way, for example, Hardit was just saying?
In elementary school, I was fortunate enough to have a separate class that was designated for science lab, where we got to actually ask these questions that we were thinking about. And we got to conduct these experiments and engineering projects. And I think this teacher really sparked my curiosity, and honestly everyone's curiosity in that room, because we left our main classroom where we, were going by the curriculum, but instead we entered another classroom where, as cliche as it may sound, our imagination was really unleashed. I always remember her when I'm tackling a new science fair project or any project in my life.
I would have to say Richard Feynman. I've read all of his biographies, and just the way that he sees the world in that curious lens, and that he still has that child in him. Even when he was much older, he would ask questions and just try to understand the world, and that has been an extremely big influence to me in how I see the world now.
Yeah, picking up on what Catherine said, that's one of the main reasons she talked about the power of elementary school, and so probably the main reason that I chose to teach primarily grade 7 and 8. We know that very, very young children are intensely curious. They want to know about everything. They ask all kinds of questions, sometimes to the point of driving their parents crazy. But it's that curiosity that is the basis of all of the innovation which Hardit identified, and somehow between the point where children are incredibly curious to when they graduate high school, if you were to graph curiosity for most kids, it typically drops off until the point where it's barely recognizable at the end of high school. So for Youth Science Canada, that's really our focus, is around changing that and making sure that that students have the opportunity to remain curious, ask those questions, investigate those problems, and then be celebrated and recognized for them. So I'm really pleased to hear from the three students that's actually at the root of their sort of inspiration.
Yes. I'd like to come back to Catherine just for a moment, if I may. And Catherine, I went through engineering school. I won't say when, but I was struck at the time by how few women there were in engineering school. And, I would talk to some of my colleagues, women in the class, and ask them, why they think that was. And they felt that it was not very encouraging for them. People didn't think, engineering was the right career for a woman at that time. And I guess there's lots of unconscious bias that has existed out there. And what can you offer? How can we encourage more balance with women in sciences?
Yeah, that's definitely a great point. And I think even from personal experience, I saw this bias arise in elementary school even. Specifically, when I walked through a toy store and the girls' toys were all pink and the boys' toys were all blue. And I remember just looking at the dolls in front of me that were all pink and really just not finding an interest in them. But then I turned around and the boys' toys all surrounded, STEM subjects. And how can I, create this Lego structure in order for it to do something else? And I was really shocked at the moment about that. And when I saw so many students, so many girls actually pulling away from STEM subjects, I think that something we should definitely change is, from an early age, just encouraging students and not labeling toys as girl toys or boy toys, and kind of introducing them to a wide array of them. Because even if some boys are interested in various toys that are labeled STEM, that doesn't mean girls aren't. And I think that that balance is tricky to find in elementary school right now, but it's something that we should definitely strive to be more open about. And actually, this problem did stay with me until high school, where I created an organization, Girls Will Stay. And that is centered around girls staying in STEM and underrepresented careers. And we actually branched out into an international organization this past year. So I think through my organization, I definitely want to break these gender stereotypes and gender barriers as well. And I really think it does start in elementary school and going to elementary school students and saying, you can do this, just be curious and don't let any boys or any other teachers tell you otherwise.
Fantastic. I'm just wondering if we could imagine in the next 100 years, where is our imagination going to take us? And what are some of the big breakthroughs? They don't have to be in health science. They could be in agriculture. They could be in energy resources. But what are some of the things that you would foresee or you would imagine will be possible in the next 100 years with what we're learning about science and engineering, technology, mathematics?
I'm sure in the next 100 years, there's going to be a kid that's like, what's the cure for cancer? How can I figure it out? And they're going to start from a young age, and they're going to dedicate their life to trying to find a cure for cancer or whatever the other obstacle is, whether it be like how Frederick Banting found insulin.
That's inspiring. A cure for cancer, my goodness, so many people every year suffer with cancer, and some survive and some don't, and absolutely a very worthwhile goal. How about you, Hardit? What do you imagine in the next 100 years?
I definitely hope that problems that affect just general human health, so that that those would be solved. So things like poverty and world hunger. I really hope that in the next 100 years, I definitely think that we can find solutions to provide a lot of sustainable food, provide tons of jobs, and provide economy to those who don't have it currently, so that everybody still has a basis for a standard of human life where they don't have to wonder where the next meal is coming from, and where they don't have to wonder where they can get shelter. All these basic necessities, electricity, all of these things, in the next 100 years, I definitely think we can make it more accessible to the communities that don't have it. And I really hope to see that going forward, and I would really love to be working on those issues as well.
Fantastic. Very, very inspiring. I'm going to come back to you, Renee. And first, do you have any thoughts? I mean, you work with a lot of science students. What would you foresee in the next 100 years?
I think there are huge opportunities. The saying that every crisis presents an opportunity, and of course we're seeing that with COVID, and additionally with the effects of climate change, and so on. And every single one of those enormously complex problems presents an opportunity for creativity, innovation, inspiration, and new ideas. And I think there's no end to the possibilities. I think the other thing that we're going to see, that was alluded to a little bit earlier, is the idea of collaboration. The students talked a little bit about collaborating with their peers or collaborating with university professors and so on. And I think the solution and the solutions that we need going forward are far less about perhaps the individual superstar effort, but more of a team effort, whether that's globally or in a lab or an engineering team or what have you, to tackle these problems in a very multidisciplinary way. And I think COVID has shown that when when push comes to shove, people can align behind a problem, work on solutions, find those solutions, get over their differences, and and focus on the problem and the solutions. And we're seeing new technologies, new ideas come out of those things. Of course, we're still living through great crisis in the healthcare system and so on. But out of it, I think, is going to come a bit of a burst of innovation to help ensure that the impacts of this are less in the future, and that perhaps we look at tackling climate change with the same level of energy and commitment and finances and government attention and so on as COVID.
Yes. Now, thinking about your group, Youth Sciences Canada, how could people that hear this podcast refer people into the program? Like how do they get involved? Because just listening to these three just incredible students who I've met today, how could more students get involved?
The easiest way, I think, is to visit our website, our youth-focused website, which is mystemspace.ca, or Mon Espace STEM in French. And that is a website dedicated to students who are just getting started on a project. They maybe have an idea, or maybe they have a project that they're just working on and want to make it a bit better. That's a great place to start. Through that, they can actually learn a little bit more about where their regional science fair is, their regional STEM fair that they could participate in. And of course, each of the three students comes from and has been involved in three different fairs. We actually have 107 of those regional fairs across the country in every province and territory. And so it's there's no student who's very far away from a regional fair that they could be involved in. But the real key is to get started and to maintain that curiosity and maybe not listen to the people, as the students have said. Don't pay a lot of attention to the people who say, "Oh, I don't think you could do that," or "That'll be too hard," or "That's too difficult a question," or nobody else has been able to figure out how to solve that problem. I think there's a passion and an intensity with youth that pushes past that. So again, I would refer them to mystemspace.ca, and we also have a website that's a little more focused on parents and teachers and so on, which is youthscience.ca, and that's probably the best place to start.
Well, listen, I'd like to thank you, Renee, for helping us to locate these three very eminent up-and-coming scientists. And I want to wish the three of you, Keanu, Catherine, and Hardit, every success in your career ahead. And I'm looking forward to you curing cancer and Alzheimer's and world poverty, and many, many more very exciting things, all driven by curiosity, and by applying scientific methods and being bold and ultimately making it happen. So thank you all so much. And this has been the Next 100 podcast, number 4. And it's been a real pleasure to be with all of you tonight. So thank you.